Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study the topic called quantum theory of radiation. And the quantum theory of radiation was given by Sir Max Planck. You can see him in the picture that I have pasted on my notes. That's our sir, Mr. Max Planck, who has given us the theory of radiation, the quantum theory of radiation. So, in the previous lectures, we have studied about the electromagnetic wave theories. The electromagnetic wave theory successfully explained many properties of electromagnetic radiation such as reflection, refraction, diffraction, interference, polarization, etc., etc., etc. But the wave theory does not explain certain phenomena like the black body radiation and the photoelectric effect. In order to explain the black body radiation and photoelectric effect, Max Planck sir in 1901 presented a new theory which is known as quantum theory of radiation, and it was further extended by Einstein sir in 1905. So, let's talk about what is quantum theory of radiation. First of all, I'm writing the wave theory, about the wave theory. The wave theory of electromagnetic radiation of electromagnetic radiation explained many properties, explained many phenomena, many properties. Let it be many phenomena, that is reflection, refraction, interference, polarization, interference, polarizations, etc., etc. But the wave theory did not explain. But this theory did not explain two phenomenons, two phenomenons, that is black body radiation and photoelectric effect. Photoelectric effect. About these two phenomena, that is the black body radiation and the photoelectric effect, we will discuss in details in the further lectures. Now, what does quantum theory, the quantum theory of radiation states? What does quantum theory of radiation states? It states that the transmission of energy from one point to another takes place in the form of small packets or discrete units called photons. So I'm writing the transmission of energy, the transmission of energy from one point to another, from one point to another takes place in small packets or discrete units or discrete units called photons or you can simply say that the flow of energy will be in discontinuous manner will be in discontinuous manner. So the transmission of energy from one point to another will take place in small packets or the discrete units, and that discrete units of energy is called photon. That small packets are coming one by one, which confirms that the flow of energy is not continuous, it is discontinuous. Now let's talk about photons. A hot body emits radiant energy discontinuously in the form of small packets of energy called photons. So I'm writing, from where do we get photons? You can say that first, a hot body called the black body radiation. So first of all, I'm writing a hot body emits radiant energy emits radiant energy but discontinuously, but in a discontinuous fashion or discontinuously, in the form of small packets of energy called photons. In a form of small packets of energy called photons. After that, my dear students, the very important point, the energy of one photon is called quantum. So the energy of one photon will be called as quantum. Now, the energy of a photon, the third point, the energy of a photon will be directly proportional to the frequency of that photon. The frequency by which the wave of that photon is moving, that will be directly proportional to the energy. So energy is directly proportional to the frequency. So I'm writing capital E stands for energy. It is directly proportional to the frequency of the photon. Now energy will be equal to h nu, where this h is called Planck's constant. The h is called Planck's constant, given by Max Planck sir, and its value is 6.626 into 10 raised to the power minus 34 joules seconds. So that's the value of Planck constant h. So this is the formula that energy is equal to the h nu. Or we can drive it further. Energy will be is equal to the h. What's the formula of frequency? The frequency is equal to the c, the speed of light, divided by the wavelength. So you can write it over here, c divided by wavelength. From here, it is proving that the energy of photon is inversely proportional to the wavelength of the wave formed by the photon. So the relation comes out to be more the frequency of the photon and lesser the wavelength, more will be the energy of photon. So I got the two formulas over here, and they are that energy is equal to the h nu and energy is equal to the hc by lambda. You will get the numericals on the basis of these two formulas. Now let's talk about the units of energy. I'm writing units of energy. As we know now that energy is equal to the h nu. What's the unit of Planck's constant? It's joule second. And what's the units of frequency? It's per second. So the energy unit comes out to be joules. So what next? Now I'm moving to the fourth point, the very important one. It says that the energy emitted or absorbed by the body can either one quantum or one photon or any whole number multiple of photons. So I'm writing the energy emitted or absorbed by the body will be whole number multiple of photons. So now let's talk about the total energy. Now I'm writing total energy. Total energy will be equal to the energy of one photon multiplied by number of photons emitted or absorbed. So now let's talk about total energy. Again, I'm writing total energy. What's the energy of one photon called? It's called quantum. And what is the number of photons emitted or absorbed called? It is called quanta. So quanta is the number of photons emitted or absorbed. So the quanta into the quantum, the number of photons into the energy of one photon will give me the total energy. So it proves that the energy is quantized. The word here is the energy is quantized, which will which we will be using in the Bohr model. So this was the quantum theory of radiation. Hope you all understood it. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.